Hello, this is Math0955, and in this video I want to cover some of the homework from the first section, the first assignment, the Chapter 1 review homework. And the idea here is we just want to make sure that you have learned all your lessons from the previous class, or things that you should know if you tested into this class. Okay, so let's click on that. There's a lot of exercises here, and we're just being very careful and making sure that we cover all of our bases. But let's dive in here and see what we're up against, and I'll just kind of go through and do a problem in each section, and hopefully it'll help you if you're having trouble. Okay, so for this first set of problems, all you're doing is substituting in values. Okay, so you have x plus 15, and then they say substitute in, so that colon is just another way for them to say substitute in the value x equals 1. So wherever you see the variable x, you're going to put a 1, and then you're going to simplify. Okay, so instead of writing x plus 15, I plug 1 in for x, I'll have 1, and then plus 15. And then all you have to do is add them together, so you'll get 16. Okay, then you come over here and type 16. 16. There we go. Check the answer. Yay. And okay, so that's pretty much what you're doing in this problem as well. So 2. I'll just do this one as well. It looks like it's written a little differently, but it's the same problem. 17 minus z. And they want you to evaluate it. So basically substitute in z equals 5. Okay. So we have 17 and then minus, replace z with 5, and so that's 17 minus 5 is 12. Okay. Generally, I try to do all these problems without a calculator. You can use your calculator, but I don't know. It's good practice to not bother. Let's look at this guy, right? So it's number 4. They have 120 all over b, and they want you to plug in b equals 8. So where we see b, all right, you're going to put in 8, and then we want to simplify this. Let's do a little bit of arithmetic here. So I'm going to divide 120 by 8. So 8 goes into 12 one time. So you have 8 here, that will be subtracting, you'll get 4, bring down the next number, so 0, and then it will be 5. Okay, so this will equal 15. There's a lot of work with fractions. Okay, so this is the same kind of problem. This is a little more complicated because you have multiple variables, but it's the same idea. So I have 6x minus 3y, and then this time we have x equals 4 and y equals 2. So anyways, you're just plugging in. So it'll be 6 times 4 minus 3 times y is 2. And then you use order of operations, so please excuse my dear Aunt Sally. So I'm going to multiply first. 6 times the 4 is 24, and then minus 3 times 2 is 6. And then you'll get 18 for your answer. And feel free, to fast forward to parts of the video which may be a little harder for you, or maybe you're having trouble. This one, so you could do a lot of these in your head. You'll probably have to write number 8 down to evaluate. Let's skip that one. Yeah, writing out, translating English to algebra, really, really important. To do, so it says 9 more than a number, so that just means add 9 to some sort of number, and you want to let the number be a variable x, so you have x plus 9, and then that's what they want, and the answer is x plus 9. So, yay. 3 less than a number, so there's kind of 2 ways you could think of doing this problem, and you have multiple guesses, so I think you get 3 chances to get the problem correct, and then if you don't get it correct, they give you a different variation on the problem. So here It's 3 less than a number. You know there's that word less than, that phrase less than means subtract. So you're going to have either 3 minus x or x minus 3, right? So 3 less than a number. Oops, my little pen thing isn't working. 3. 3 less or x minus 3. It turns out that the correct answer is this one. Okay. So whoops, sorry, it's this one. So you're taking 3 away from some number. So it's going to be x, and then you're removing the 3. So it's x minus 3, not 3 minus x. But as I said, you have multiple guesses. So if you don't get it right, whoops. Oh, no, I decided to put in the other one. So you can see I have multiple guesses. So if you don't get it right on your first try, you can just put in the other variation and see if that works. Okay. So the sum of a number and 7. So that's just going to be x plus 7. So great. 14 less than. That less than means you're subtracting away the 14. So you have 14 less than the product of 3 and a number. So the product of 3 and a number is 3x, and then you're removing 14. Right, so 3x minus 14. Let's make sure that's right. Yay. Okay, and then, okay. So more of that. Here's another substitution, but this time they want you to work with an equation as opposed to an expression. So an equation, you'll know it's an equation because you'll see an equal sign. Here we go. But it'll work the same way as above. All you're going to do is wherever you see an x, you're going to put the 3 in for x. So here we have 3 plus 18 equals 21. And what you're looking for is to simplify both sides. On the right, it's already simplified, but you're going to simplify on the left, and you'll have 21. And if both sides are the same, you're going to say that the number 3 is a solution to the equation. So here, yes, because the number 3 makes the statement true, and so on and so forth. So say number 15, 26 minus y, we have, okay, so 15, 26 minus y equals 13. They want you to check if 12 is a solution. So basically when you put it in, do both sides end up being the same? So 26 minus 12, no, right? So 26 minus 12 is not going to be 13. 26 minus 12 is actually 14, which does not equal 13. So that means it's not a solution. You just put not as a solution, yay. Okie dokie. Same game there. You're just plugging in and making sure both sides are the same. Same game here. Same game here. Here's another, translation, but here you're looking to form an equation. So you'll have phrases that represent an equal sign. So in this case, the word gives is the same as the equal sign. So 19, 5 less than 3 times a number. So 3 times a number and less than, so you're taking away 5, gives, so that means equals 16. And then you could just type in your equation here, 3x minus 5 equals 16. And hopefully the computer will be happy with that. There we go. Okay, great. Same game here. They just want you to form an equation. Mixed fractions. It turns out I'm not a big fan of mixed fractions, so you're not going to see those in my class, but they're in the homework because we expect you to be able to deal with them. There are a lot of jobs that use mixed fractions. For example, cooking. If you become a chef or something, you're going to have to know how to do mixed fractions. So the way it works is you're going to multiply 7 times 2, so you do a multiplication there, and then you're going to add that result to the numerator, and you're going to put that in the numerator and use the 2 as your denominator. Okay, so let me write that out then. We have 7 times 2 is 14, and then plus the 1, okay, so 7 times 2 is the 14, and then plus the 1. And then that's all over this 2 here in the denominator. So 14 plus 1 over 2. Sorry about all the different colors. That will be 15 halves. Okay, so typing it as a fraction, 15 halves. Okay, and you know, so on and so forth. So again, try to do these without a calculator. Just get used to it. Okay, so how do I convert this to a mixed fraction then? You have to do long division for these. So it's basically just saying 11 divided by 5. It's the same as 11/5. So 11 divided by 5. You're going to say 5 goes into 11 2 times. So 2 times 5 is 10. And then you subtract. 11 minus 10 is 1. So then you bring down, so that's the idea. So you don't worry about this remainder thing, but well, honestly, you could write it like this. It's 2 1/5, right? 2 1/5. And notice if you reverse the process, so again, multiply 2 times 5 and then add the 1 all over 5. That will be 10 plus 1 all over 5, which is 11/5. So hopefully that made some sense. I apologize. I butchered the explanation there. Whoops. I just wrote in the same thing. We need to hit this little button down here to input the mixed fraction. Did you see what I hit? Let me click this out, get rid of that. There's a mixed fraction button there, and then you could go through and input the 2 and 1/5. Let's do another one of those so it's just clear. I don't think I made that very clear how I find that. So 19/4. Okay, so I'm dividing 19 by 4. So you figure out how many times 4 goes to the 19. That'll be 4 times, right? And you'll have 16. 4 times 4 is 16. Then you subtract, and you have this remainder thing. So to rewrite it as a mixed fraction, you're going to put the 4 up here, and then you're going to write 3/4. Okay, so it's 4 and 3/4. So it's this clockwise rotation that you can use. And then you can check it. 4 times 4 is 16, plus 3 is 9, all over 4. And of course, you have to hit the GUI button. 4 and 3/4 should answer. Like I said, I'm not going to be doing a lot of mixed fractions, but there are kind of, we kind of turn it into algebra and use variables. So later on we'll do what's called long division, maybe not in this class, but in the next class. And you'll do the same process. So knowing how to do long division is kind of important. But factorization, so is the thing prime or is it, sorry, my cursor stopped working. Okay, so factoring numbers, right? And that goes back to the factoring tree. So you have 77, and then you kind of say, what goes in the 77? Well, 7 divides 77, and then you have 11, so 7 times 11 is 77. And then you can't factor either of those. There's no numbers besides the number and 1 that divides in the 7, right? The only things that divide in the 7 are 1 and 7. So once you get there, the number is prime. So 77 is not prime because you could factor it into a number other than 77 and 1, right? You could factor it in the 7 times 11. So this thing is composite, and the prime factorization, you just put the numbers from your number tree, okay? Hopefully it'll give us another one, yeah. So 28, we have 50, and so I know 2 goes in the 50, so 2 and 2 times 25 is 50, but then I could keep 2 is prime, but I could keep factoring 25, so that's 5 and 5. And so the factorization are the leaves on this tree, right? So it's 2 times 5 times 5. So it's composite, and our numbers are 2 times 5 times 5. You can probably write 2 times 5 squared, if you know what that is. but I think that's going to work for us. Okay. I believe 41 is prime. It's not divisible by anything except 1 and 41. So there's some of those in there, and so on. Okay, great. Reduce in lowest terms. So if you could divide the top and bottom of your fraction by a number, it's reducible, right? So 35 over 40, I can divide the top and bottom by 5. Okay, so in the top, 35 divided by 5 is 7. In the bottom, 40 divided by 5 is 8. So the simplify is going to be 7 over 8. Okay. There's other ways to do that operation. You can factor, right? And that's going to be the approach we want to use in our class. 15 is the same as 3 times 5, and then 25 is the same as 5 times 5. And then you could remove common factors. So you can remove the 5 over the 5 in the numerator and the 5 in the denominator, turn that into 1 over 1, and then the result is just 3/5. Okay. So there's different approaches to simplifying, and it'll be advantageous for us to use this factorization. Okay. Multiplication of fractions, so of course we want to, in order to do this operation, what we do is multiply straight across, right? So it's 5 times 1 in the numerator, all over 2 times 7 in the denominator, and we get 5 over 14. And you want to simplify if possible. In this case, there's no common factors to divide top and bottom by, so you just write 5 over 14. Here's another one. 8 times, so this one, some reason gives people trouble. 8 times 4 over 5 is the same as 8 over 1 times 4 over 5. And if you multiply them, so you could always rewrite any integer, in other words, numbers like -1, -2, 0, 1, 2, 3, 4, as the number. So for instance, if you have 5, you could rewrite 5 as 5 over 1, right? So to make things line up, for the multiplication, we can write 8 as 8 over 1, and then you just multiply the numerators, which would be 32, all over the denominators. 5 times 1 is 5, and that would be your answer. Okay. Oh boy, so more of the same, but with some simplification is awful helpful. I have 1 over 12 times 6 over 7. 6 over 12 is the same as 1 over 2. Okay, so you can simplify when you're doing multiplication like this, and then just multiply straight across. It's 1 over 14. Okay, let's move on to the next one. Division is the same as multiplication by a reciprocal. So to do division, you have 3/5 divided by 5/7. What do? You replace the division symbol with multiplication, and then take the reciprocal. In other words, flip the second fraction, and then we can multiply. So 3 times 7 is 21. 5 times 5 is 25. Here we are at number 40. Again, if you see an integer like the number 3 I'm seeing here in this problem, you want to rewrite it as a fraction, right? So I have 27 over 7 times, well, one step at a time, right? Let's rewrite 3 as 3 over 1, and then we'll go ahead and rewrite it as times the reciprocal, 1 over 3. 27 over 3 is the same as 9 over 1, and then multiplying straight across, we have 9 all over 7. What's next? Some more of this, more division. Okay, on to addition. So if you have common denominators, it's easy, right? But this is a problem where it's not a common denominator. So how do I get a common denominator? you have to multiply the denominators in order to make both denominators the same, right? So to make the first denominator the same as second, it's missing a factor of 2. So I'm going to multiply top and bottom by 2. And the second denominator, it's then missing, because you want to make the second denominator the same as the first denominator. So it's now missing a factor of 5. So I just multiply top and bottom by 5. Then I can add these guys together. So I'll have 2 over 10 plus 5 over 10. And to add them, you just add the numerators over the common denominators. So you'll have 2 plus 5, which is 7, all over 10. Okay, more of the same, but a little bit more complicated, right? So here we have 44, 3 over 14 plus 3 over 70. Now you could just multiply the first denominator by 70 and then the second denominator by 14, but that is a nightmare. It's going to get some real big numbers. So the method of choice is to factor the denominators. So the first denominator is 7 times 2, and then the second denominator I can rewrite as 7 times 10, but 10 is the same as 5 times 2. And then I could try to make the denominators the same by multiplying in factors. So to make the first denominator the same as the second, you need to multiply in what's missing. So I have a 7, I have a 2, I need a 5, right? So I multiply top and bottom by 5. And that second denominator, everything is there. It's the same, right? They're both the same denominator, so I don't have anything else to worry about. So the first fraction will become 15 over 7 times 2 is 14 times 5 is 70. And then the second fraction is just 3 over 70. And then you're good to go. So 15 plus 3 is 18 all over 70. And then we could simplify that expression. 18 is the same as 2 times 9. 70 is the same as 2 times 35. And you can move the 2's, and you end up with 9 over 35. Okay. If I'm going too fast in any of these problems, you can always slow the speed of the recording down. There's in YouTube, there's a way to do that. Let's go into YouTube real quick and let's see if I can find a video that's not too weird. Here's a mathy one. Okay, so sorry about the ads. Yeah. Okay, so geez, they're really sticking it to me. Okay, hold on. Skip ad. Okay, so let's say I'm watching this math video and the dude is just going way too fast, you know, or maybe I don't even like his voice. If you don't like my voice or you don't like their voice, usually you could do some subtitles, which is nice, but sometimes the subtitles aren't all that great because I'm not, you know, literally going in and typing out all my subtitles. It's a matter of it being auto-generated, right? So there's going to be mistakes in there. And not only that, because I'm talking about numbers and it's a kind of a foreign language, it might be a little off. So I'm sorry if you don't like my voice. I try the best I can. Anyways, you can go over here to this thing and go to playback speed and literally have the dude go slower. Okay, so let me unmute him. Okay, so let's say he's going way too fast for me. So I'm going to go like that. And then he just slows down. That can be even worse. But I'm just going to mute him so I don't have to listen to that nonsense. You could get the subtitles so it'll kind of put out, you know, what he's saying, but at least I can see what he's doing, and he's going a lot slower. And you know, some of these math people, they just love math so much. It's like adrenaline for it's like, I don't know why some people fear math, like math, they have feelings of anxiety. Some people have just been programmed that they love math. So you think about all the emotions you can have when you're doing math. There's probably somebody out there who feels who gets laughter every time they see math. I imagine, but I don't know. I think a lot about anxiety because I think a lot of people have math anxiety, and I try to think of ways to reduce that. And it's hard. It really is. Even for me, I have some subtle math anxieties. I hope that doesn't rub off on you. Okay, so anyways, let's get back to work. Here's a subtraction problem, but instead of adding the numerators, you're subtracting the numerators. Here is one of these. Substitute in the number and see if it works, except there's fractions involved, so maybe that's a little more complicated. Let's try 47. Okay, so I have 14 minus 1/5 z equals 1/2 z, and then we have substitute in that number 20. So I got 14 minus 1/5 times 20 equals 1/2 times 20. Okay, so I mean you could turn 20 into 20 over 1, but the long story short is you kind of can think, how many times does 5 go on the 20? Well, what is 20 over 5? 20 over 5 is the same as 4 over 1, right? So it's going to be 14 minus 4. On the other side, 20 over 2 is the same as 10 over 1, so you're going to end up with just 10. And then 14 minus 4 is 10. The other side is also 10, so therefore it's a solution. When both sides are the same, it's a solution. If you don't like that, you could think of 1/5 times 20 as 1/5 times 20 over 1. Maybe that makes it a little easier. And then you just have 20 over 5. 20 divided by 5 is 4. Or you can think of 20 as the same as 4 times 5 over 5, and then the 5's cancel, and you get 4. Yeah. So there's a lot of different ways to do it. It just kind of comes down to whatever's going to click for you, and it can be a little overwhelming, but hopefully over time you can get it. Okay, so this is another nasty one. This is a really nasty one. Let's go ahead and take a look at it. It's, what is it, number 48. So we have 3/5 y plus 2/3 y equals 1/2. We want to see if this 15/38 is a solution. So wherever I have the y, I'm putting in the 15/38. On the right-hand side, I have 1/2. So I'm going to, 15 over 5 is the same as 3 over 1. And then 3, does 38 go in? I don't think it does. So I'm stuck with the 38 downstairs. This will end up being 9 over 38. 3 times 3 is 9 over 1 times 38. Plus, and then 3 goes in the 15 5 times. So I'll have 10 over 38. 9 plus 10 is 19 over 38. And of course that works. So you can divide top and bottom here by 19, but it's 1/2. So that dude is a solution, and we're good to go. Okay, oh geez, look at this one. Another nasty one. Let's try it. So I have 1/2 times x minus 7. Let's just go ahead and put x in there, right? X is 23. So I have 23 minus 7 equals 1/5 times 23 plus 2. And then you don't forget there's a plus 3 over there as well. Okay. So I have 1/2 times 23 minus 7. So be very careful here. I think that's 16. And on the other side, I have 1/5 times 25 plus 3. And then order of operations, I have to do multiplication first. So I accidentally hit my microphone button. Hopefully you can still hear me. 1/2 times 16 is 8. 1/5 times 25 is 5. Plus, oh, that one works. So 8 equals 8. It is a solution. Yay. Okay, another nasty one here. I'll leave that one for you. Oh, this one's kind of funny. Rate a positive or negative integer that describes the situation. So a gain of 28 pounds. You're either going to put 28 or you're going to put negative 28. So you think of gain, that means plus, right? You're adding something in. So I'm going to put a positive 28. Okay. Average depth. So if you're going below the surface of the ocean, that's got to be a negative, right? Negative 1, 2, 3, 6, 8. Okay. And so on. So that's what those are about. Writing as decimals, what you have to do is long division for these. Problem 54, 1/2 is the same as 1 divided by 2. So you get 1 divided by 2. So the 2 does not go in the 1, so you just put a 0, and then you get a decimal place. And then put our zeros there. So how many times does 2 go in the 10? So that's 5 times. And then subtract, and there's 0, so no remainder, so the decimal terminates at 0.5. And some of them use so much, you just kind of know it after a while. 1/2 is the same as 0.5. What is the same problem? That's weird. This one's, 3/8. Here's a repeating one. Let's investigate that. So 57 at 1 divided by 11. So 11, and then I'm dividing into 1. So 11 does not go into 1, so then I'll put my decimal in there. Put a 0. 11 does not go in the 10, so another decimal. And then another 0. So I think 9 goes into it 9 times, so you'll have 99. 100 minus 99 is 1. So then you'll have another 0, bring down the 0, so 0 times, and then it's going to start repeating, right? So then we bring down, put in another 0, so it'll be 100, so that'll be 9, and it looks like it's going to be 0, 9, 0, 9, 0, 9. So once you kind of see the pattern, then you're going to write it out like this with a bar over the repeating portion. Okay, so it looks like it's 0, 9 repeating. These are always weird. So the way these numbers work, so you start with the natural numbers. So the natural numbers are just the counting numbers, like 1, 2, 3, etc. That does not include the number 0, right? When you go out to the whole numbers, then that includes the number 0. Okay, so the whole numbers are just the natural numbers plus the number 0. So you'll have 0, 1, 2, 3, etc. Then you go out to the integers, and the integers are just the whole numbers, and then you tack on the negatives of the natural numbers. Okay? So the integers are going to be numbers like -1, -5, 0 is in there, and then the positive counting numbers as well. Okay, so these are integers. And then rational numbers, you throw in fractions, which includes those decimals, the repeating decimals and everything. So rationals. So you get fractions now, like 1/2, 0.5. That number we just saw, 0.09 repeating. All of the numbers from before, so the number 0, the positive counting numbers, the negative counting numbers, right? And then the irrational numbers are separate from all that. So the irrational numbers are going to be numbers like pi and square roots that don't work out. Like the square root of 9 is actually equal to 3, so that's actually a natural number, but the square root of 5, we don't know, right? So that would be irrational. And then all numbers taken together are called real numbers, right? So if you then kind of draw a circle around everybody inside, including the rational and the irrational, are called real numbers. So everything is basically a real number. Okay. Okie dokie. So in this problem, first they want you to list the natural numbers. So like I said, the natural numbers are just counting numbers. And you look at this set of numbers up here in the curly brackets, you don't see any counting numbers. You might think 0, but 0 isn't a natural number, it's a whole number. So I don't know, but then you see square root 49, which is 7. So that's the guy. Okay, that's our only natural number in the set. Okay. And as you work out, you're going to have to input these numbers, right? So as you go to the whole numbers, it's going to also include the natural numbers. So you're going to be putting in the number before it, right? So you're going to include also square root 49, but then you have the number 0. And what I like to do is just kind of copy these numbers, and then the first thing I do in the next problem is the next part of the problem is to substitute. So I put Control C, and then in my next question, I can just Control V it, and I have those numbers from the previous set. Okay, so integers now include the negative counting numbers, so negative 11. And again, I'm going to copy these so I can copy and paste. Control C. And then I'm going to Control V it. And the rational numbers, so now I'm including decimals and fractions like negative 5, 6, and then decimals, comma 0.8. And then I want to copy these. Control C it, and check answer, yay. And then the irrational numbers are not, these are separate, right? So the irrationals and the rationals are separate characters, and the irrational numbers in this set are the square root of 7, and then pi, okay? Okay, great. And then finally, everything is a real number. So I'm just going to Control V everything from the previous place, and then add in the square root of 7, and add in pi. Yay. Okay. And then they got some trick questions here. A whole number, that's not a natural number. That's the number 0. Rational number. Okay, so those are clever. Inequalities, so you're thinking number lines here. You can graph these. Negative 18 is to the left of negative 11. So when that happens, you're going to use the less than symbol. So this is less than, and they give you that. You look at the little button below, they give you a less than symbol. Negative 2.5 is less than 1.5. Fractions are always kind of weird. You want the common denominator, and then you just kind of look at the numerators, right? So if you have negative 5/8 and you're comparing it to negative 11/8, as long as you have the same denominator, you can just compare the numerators. And so negative 5 is greater than negative 11. And you can kind of do it that way. But yeah. Okay, commutative law multiplication. So commute, your commute to work, you go back and forth, right? So what's that about? That's about changing the order. And when they say multiplication, it applies to the multiplication part of this expression. So where is the multiplication part? That's the 5 times y. So in order to use the commutative property, what you do is just rewrite it y times 5. And these properties are the rules of math. You can kind of think of math as a game. And there's all these rules, and all the rules kind of impart a structure to mathematics. And you could study that structure. If you want to keep studying math, people sit around and say, well, what would happen if I had this rule? And what would happen if I had this rule? And they just go crazy with it. But, anyways, this will be y times 5 plus 16. Okay. Commutative law of multiplication again. So where is the multiplication is kind of the issue. 5 plus x, and then it's times 7, right? So to do the commutative property, to rewrite the order, you'll rewrite it as 7 times 5 plus x. Associative property, so your associates, who you hang out with. And what they do is use the parentheses to rewrite this thing. So you have in number 67, you have 11 plus 8 plus x, and they're associating the a and the x, right? So what you want to do is associate two other numbers that are close to each other. So I'm not going to associate 11 and x, I associate the 11 and the 8. And that will rewrite it, and then I think they want you to just rewrite it first and then simplify. Believe it or not, you can make math like new math systems that don't follow these rules, right? That's what I was talking about. It's like a game, and we just study one sort of math system. This math system is the most important math system, but anyways. 11 plus 8 is 19, and then they want you to put that in there. 19 plus x. Yay. Same sort of deal here, except multiplication property association. We have 68, then I have 10 times 9 times x. Instead of associating 9 and x, you'd associate 10 and 9. Right, times x. So you'll write that in, and then you'll multiply it out, so it'll be 90x. Yay. And then 90x. All right. Distribution property, so hopefully you kind of know what that is. 69, 9 times a plus 4. So you just multiply these two numbers. So it'd be 9 times a plus 9 times 4 is 36. And that should be it. Let's skip ahead. That'll be 10x plus 20. Ooh, a fraction. So let's try that one. So we got 1/6 times 24x plus 30. 0. So sorry, not 0. So this will be 1/6 times 24x plus 1/6 times 30. 24 times 1/6, that will be 24 over 6, which is just the same as 4x. And then this will be 30 over 6, which is just the same as 5. So it'll be 4x plus 5. Multiple variables, so it'll be 11x plus 11y. Simplifying algebraic expressions now, so 73. What you're doing is combining like terms. So I have 13 x's minus 8 x's. How many x's do I have left over? So that's going to be 5 x's, right? So it's like 13, if I have 13 apples and I take away 8 of the apples, how many apples do I have left? I have 5 apples. And how do you think of that? You just think of, well, I'm subtracting 13 minus 8. Simplifying this weird algebraic expression, the parentheses are not necessary in this problem. So to simplify it, you could just kind of reimagine it as 9 plus x plus 20. Okay. And then you can add together the 9 and the 20, you'll get 29, and then plus x, and that would be your answer. Usually we like to put the variables first, so let's put x first, plus 29, and then put this. Okay, good. More combining like terms, combining like terms, combining like terms. Adding negative 1 plus 1. So these guys, if they had the same sign, you add the numbers together, right? So it's a negative plus a negative. So you add 18 plus 18, that's 36, right? And then you borrow the sign of the numbers. So in this case, it would be negative. A negative plus a negative is negative. A negative plus a negative is, so this would be negative 13, right? I tried to do these without a calculator. Get some fractions. So adding the numerators, it would be negative 11 plus negative 7 is negative 18, all over 18. So that would be negative 1 when you simplify. When you have different numbers, so a negative plus a positive, you have to subtract the numbers. And then you take the sign of the bigger number. So 8 minus 5 is 3, and then the bigger number is 8. So you borrow the negative, so it would be negative 3. Positive plus a negative, you're subtracting. Here you need a common denominator on top of everything else. So 84, I have 7/9 plus negative 1/3. So in that second number, that second fraction, I need to multiply top and bottom by 3. And then it should be good to go. So I have 7/9 plus a negative is the same as subtraction. If you want to just write minus, then 3/9. And then so that'll be 7 minus 3 over 9, which will be 4/9. More of that, so you get a lot of practice with fractions. Adding numbers, so you can add 2 at a time if you want for stuff like 87. So 2 plus negative 8 plus negative 7. So 2 plus negative 8, you have to subtract the 8 and the 2, so that would be 6. The bigger number is 8, so you get negative 6 plus negative 7. Same sign, add the numbers together. So 7 plus 6 is 13, and then borrow the negative, so it would be negative 13. Yay. Negative negative is positive, so that 17 minus negative 12 is the same as 17 plus 12, which will be 29. Some stuff here. And then you have all these rules of negative times a negative is positive. A positive times a negative is negative. That kind of stuff. So in this problem, you have negative times a negative, which would be positive, and then times another positive will be positive. Okay, and you could break it down into the pieces. So you have negative 5 times negative 2 times 3. So just do 2 at a time, right? So negative 5 times negative 2, negative times negative is positive. 5 times 2 is 10, and then multiply the 3. So positive times positive is positive. 3 times 10 is 30. Some more of the same stuff there. The division process, the way signs work with division is the same kind of deal. A negative divided by a negative is positive. Negative divided by a positive is negative. A positive divided by a negative is negative, and a positive divided by a positive is positive. Okay. In this problem 96, I have a negative divided by a positive, so that's going to be negative. 20 divided by 4 is 5. Negative divided by negative is positive. 0 divided by anything besides 0 is 0. Okay, so 0 over anything is 0, except if you're dividing by 0, and we worry about that later on in life. Okay. If you divide by 0, that's bad news. That's when it's going to be undefined. division, it's just multiplication by reciprocals. And now we have order of operations. Please excuse my dear Aunt Sally. So parentheses, exponents, multiplication, division, add and subtract. And remember, when you do multiplication and division and add and subtract, it's not that multiplication becomes before addition or that addition comes before subtraction. You do this in order from left to right, regardless of multiplication or division. And I'll show you an example of that here soon. Okay. It's a non-issue in problem 102. We have 22 plus 6 times 6. So doing multiplication first, 22 plus 36, and then you could do your addition. You get 58. Here is where you see the issue. Okay, so problem 103, I have 20 divided by 5 times 4. So you do it, even though you have a division coming, you would think maybe I have to do the multiplication first, right? Because of PEMDAS. I have to do multiplication before division. No. If you multiplication and division are kind of seen as the same operation, and you just tackle them from left to right. So the one I see first is the division symbol, so I do that first. Okay? Just like I'm reading a sentence in English. I read from left to right. So I do whatever comes first. The division comes first here. So at 20 divided by 5 is 4. And then you do the multiplication. So it's going to be 16. Same deal here. You may think, well, I have to change the order now based off the last problem, but no, you do it from left to right. So 4 times 8 is 32, and then 32 divided by 2 is 16. It's not like some deep mathematical theorem that is causing this. It's just a matter of notation and being able to communicate things to other humans, right? We all want to communicate in the same way, because if it's not clear, then we interpret it in different ways. And you've definitely encountered that in your English classes. You know, you have to use periods. I don't know the order of verbs and predicates and stuff. You always put I believe the verb before the subject, right? He ate a lot of cake. So I guess he is a subject. Well, I'm going to get myself in trouble. I'm not an English major. Okay, so 105, let's take a look at this guy. 16 minus 2 times 3 plus 4. In other languages, they change the order of the like we would say he eats cake. In other languages, they might say cake eats he, and that would make sense to them because they've all established that order, you know. Anyways, here, what do? We do the multiplication before the addition or subtraction. So we'll have 16 minus 2 times 3 is minus 6 plus 4. And again, you have this issue, do I do addition or do I do subtraction? You do it in order from left to right. So 16 minus 6 is 10. And then 10 plus 4 is 14. Honestly, it won't make a difference with regards to addition and subtraction. It's really the big issue is when you have the multiplication and division. That will become the big issue, because you can do it either way here, right? You can say, well, this is the same as 16 minus 2, which is the same as 14. So it's mainly the multiplication and division, I believe, that is the issue. Okay. See if there's any other ones. Oh, a bunch of parentheses. So work inside to the out, right? So 106, we have 5 times 2 times x minus 2 plus 1. So I work inside first. And on the inside here, and here, there's a multiplication right here. So you do that multiplication first, and that requires distribution. So I have 5 times 2x minus 4 plus 1. Then again, you're working inside the parentheses to simplify that as much as possible. I'll add the 4 and the 1 together, so it would be 2x minus 4 plus 1 is minus 3. And then you just do distribution. The bracket versus parentheses, they're the same. Okay, it doesn't really matter which one you have. You just treat it the same. So you can treat this, it's the same as 5 times parentheses 2x minus 3. Same stuff. We just use different types so you could, hopefully it doesn't become too confusing. So if you see a bunch of parentheses, it kind of becomes confusing. So anyways, you distribute 10x minus 15, and then you're stuck. You can't there's no more like terms, basically. There's 10 apples and then 15 carrots. You can't combine those. And then another one of those, make sure you distribute the negative there. So 107, you have 4 times 4 minus y plus 3. So this will be distribute the negative first. So again, you're working inside out. So you work in here, and negative in front of a parentheses. The way you can think of that in your brain is just think of this is the same as plus a negative 1 times y plus 3. Okay? So you're going to distribute then this negative 1, and you'll have 4 plus negative y, which is the same as minus y, plus negative 3, which is the same as minus 3. Then you can combine like terms. 4 minus 3 is 1. And then finally you could do this last distribution. So it'll be 4 minus 4y. Let's see if that's right. Make sure I'm not misleading you. 4 minus 4y. Yay. Is this the last problem? Wow, that one looks really hard. So let's try that one. 108. 2 minus 2 times 2 minus 6y minus 5. Okay, so, and again, you're working inside out. So you want to work in here first. And to work in there, I'm distributing a negative 1. Or you can just think of it as distributing this negative. So this will be 2 minus 2 times 2 minus 6y, and then plus 5. And then in there, I need to simplify. So you're doing parentheses first. Please excuse my dear Aunt Sally, parentheses first. Simplify the parentheses. Don't do the 2 minus 2 out in front, right? Okay, so anyways, 2 plus 5 is 7, minus 6y. And then you have a multiplication there, right? So it's really 2 times that. So negative 2 times 7 is negative 14. Negative 2 times negative 6y is plus 12y. And then we can do our addition and subtraction. So the 2 and the 14 will be negative 12 plus 12y. And I think that'll do it. Right? Whoops. Yay. Okay, so that's that first assignment in your MyMathLab. It's a good review. This is all stuff that you should know, believe it or not, from your previous classes that we're going to be using now here in 0955. Okay, so if you're having trouble, you need to really think about, maybe this I need more help. I definitely need to go, and do some review. You can go online and find some review places. You could go of course, to My Tri-C and get the tutoring there, right? So, and you just probably type in Tri-C tutoring, and I'll talk about tutoring in class as well. I want everybody to go see the tutor just to figure out how it works. So you could just drop in there anytime you want. It's kind of weird. I don't know why they call it the Tutor Ocean, but that's kind of where you want to go, believe it or not. So you just go to the Tri-C Tutoring and then hit the Tutor Ocean, which is, why couldn't they call it something a little bit? Okay, so anyways, and then you just say, okay, I want to go in person. There's nothing today, so things aren't set up yet because it's not exactly. How do I go ahead in time? want to go. Oh, this is crazy. Okay. Okay, so let's say on Monday I want to go in there, um, and for in person they show all kinds of people, um, for in that's, I guess they have different languages. Am I in the math? Yeah, I know certain people are math people. Chris is awesome. He is super smart. So I want to go see Chris from 1 to 5, and I believe I can do that in person, right? And then what kind of appointment do you want? Um, I presume you could just walk in and do that then, but you want to check and make sure somebody's there. Michael is also another math guy. You could probably just go talk to Michael and he'll help you out. And okay, just go work with this person or something. You also have online appointments. I think this is so no rendezvous required, no reservation required is basically what that is. So you have two choices. You can do the choice where you have to get an appointment, or you don't need an appointment. But if you're going to be in person, you might as well just walk over there. It's in the back of the library. So the library's over by the bookstore. It's to the right of the bookstore, I guess. And then you just go way to the back of the library. So there's a library with all the books, and then you go through another set of doors, and you go all the way into the back, and it's on the left, behind all the computers and stuff. You literally just wander around and ask people, where's the tutor center? They're going to tell you where it is. And again, I want everybody to go there just to feel it and figure it out in case you get in a jam and you need some help and I'm not there, and okay. But anyways, I'll talk about that more in class. Of course, I'm going to be harassing you with that. But anyways, let's cut it there, and I hope this helped a little bit. Okay, I'll see you next time.